Hello and good morning, good afternoon, good evening to our audience. Welcome to today's webinar on moving your tape backups to AWS in 30 minutes. My name is Bhavin Patel and I'm a product manager with the AWS Storage Gateway team. I'll be presenting here the work of Storage Gateway team and I'm joined today by my solution architect colleague in UK, Mohammed Adli. We are also joined by several Storage Gateway colleagues to answer your questions related to the content of this webinar live or through the Q&A window. There are several objectives of this webinar. At the end of this presentation, we would like you to walk away with an understanding of the options to back up your on-premises data to AWS. What is AWS Storage Gateway? What is Tape Gateway? What are its capabilities and benefits? How does it work? And how you can utilize Tape Gateway to protect your data in the AWS cloud. I will kick off the webinar today with the slides and hand it later to Mohammed, who will do a demo on how easy and quick it is to start using Tape Gateway to back up your data to AWS. So let's discuss the backup problem facing you, our customers, at the macro level today. According to IDC, the world's information is doubling every 2 years, and the volume of digital data will grow 40 to 50% every year. The total digital data in the world is expected to reach 160 zettabytes by 2025. That's really a lot of data. If you are leading the IT efforts for storage or backup and recovery in your company, your challenge is not only where to store this data for legal and compliance purposes, but also how you can protect this data so that you can recover your data when there's a problem. And you need to do all this while keeping an eye on your budget and costs. Let's take a look at the traditional options available to you for backup and recovery. So what do the legacy backup and recovery architectures look like? So this is before cloud. The slide here shows a traditional backup and recovery approach. The application servers are protected by a media server or a backup server, running backup management and orchestration software, reading data from your primary storage systems, and writing a backup copy of that data to either local nearline disk or to tape. Typically, the recent application data with the most stringent RPO and RTO requirements is written to disk-based systems that reside on premises. Then the data is aged to tape, which is sent to an offsite vaulting provider or to your own offsite vaulting facilities for long-term storage and protection. What we have heard from customers is that they would like to move from the sometimes thankless task of managing this backup infrastructure, retire their expensive purpose-built data protection appliances and their physical tape libraries, but do it in such a way that they're not disrupting their existing data protection practices and a way that allows them to maintain their existing RPO and RTO requirements. And this is where the cloud comes in to help overcome these challenges. AWS can help protect data managed in your own data centers by backing it up to the cloud. All kinds of customers use the cloud to replace tape, streamline backup management, and simplify archival processes. AWS provides many services ranging from storage for storing your backups to online and offline data movement for bringing the data from on-premises to AWS, and to data security and management to protect and manage the data once it's in AWS. You can utilize the object stores such as Amazon S3 for your backups or low-cost cloud storage service such as Amazon Glacier for data archiving and long-term backups. You also have the options to use block storage with Amazon EBS or file storage with Amazon EFS. AWS supports the widest range of options to move data into or out of the cloud. And this native data mobility capabilities on the very left-hand side here include services such as Direct Connect, Snowball, AWS Storage Gateway, S3 Transfer Acceleration, Kinesis, and CloudFront. And then on the right-hand side, you have a comprehensive data security and management services portfolio for monitoring, security, access management, analytics, and automation services. Essentially, AWS offers a complete set of tools and resources to build scalable, durable, and secure backup and restore solutions for your on-premises data. So what are the benefits of backing up to cloud compared to your existing on-premises solutions? The AWS Cloud Storage services are built for optimal durability and availability so that you can access your data anytime, anywhere with maximum amount of uptime and 11 nines of data durability. There are multiple storage options available to you, as I was discussing in the last slide, which include object storage, block storage, and file storage to meet your performance, data criticality, and scaling and compliance needs. AWS customers also have access to virtually unlimited storage capacity to accommodate the growing data volumes. You can scale consumption as your needs change without administrative overhead or hardware procurement cycles. You only pay for what you consume in AWS, and the legacy approach of lengthy capacity and capital expenditure planning is no longer needed. AWS also offers simplified administration through automation, so you can regularly back up data based on the policies that are dictated by your business teams and do easy retrieval of that data when needed for restore purposes. And above all, the most important benefit is that once your data is in the cloud, and depending on what format it is available in, you can start to leverage other AWS services ranging from big data to analytics to machine learning and AI to really put that data to use to drive better business outcomes. Now that we have looked into the legacy way of doing backups and also looked at the cloud benefits, let's dig into what are the options available to you for backing on-premises data to cloud. So on the left-hand side here, you have your on-premises data sources needing to be backed up to the right-hand side AWS cloud. We like to think of you having as three options to back up your on-premises data. The first one here is DIY or do it yourself. So you have your own apps, you have connectivity and access to AWS, and to stitch them together for backups, you are using your own homegrown scripts or tapping into AWS APIs rather than using some off-the-shelf backup software. You maintain your own catalog of backups and retrieve the backups when necessary. This is a bit of a crude method, as you can see, but it's always an option when you can't find a solution that meets your needs or your budget. The second option here is what we're calling is cloud connectors. Essentially, most major backup software vendors integrate directly with Amazon S3, and preserve media catalogs and existing backup jobs in their software. Customers can simply replace their backend data protection storage infrastructure seamlessly with cloud storage without having to change any of their existing backup environment on premises. And then the third option here is to use AWS Storage Gateway. The Storage Gateway is ideal for customers that want to work with the data locally as well as in the cloud. For backups, this means integrating with your existing systems and applications using standard storage protocols while offering virtually unlimited backend storage using cloud. The AWS Storage Gateway service is a hybrid storage service that enables your applications to seamlessly use AWS storage. Later on in the presentation, I'll be talking about Storage Gateway for backup use, but let me talk about Storage Gateway generically first, as there are several different use cases for it. So the Storage Gateway is typically deployed in your existing storage environment, in your data center, or a remote office or a branch office. The left-hand side of the diagram here, you connect your existing applications, storage systems, or devices to the Storage Gateway. The Storage Gateway provides industry-standard storage protocol interfaces such as file, block, or tape, so applications can connect to it without you having to rewrite the application or make any other changes to your workflows. The gateway, in turn, connects those applications and workloads that you see here on the left-hand side to AWS storage services, so you can store your data securely and durably in Amazon S3, Glacier, or as Amazon EBS snapshots, the right-hand side of the diagram. The Storage Gateway service is also integrated with other services such as CloudWatch, CloudTrail, IAM, KMS, so you can get an extension of AWS management services locally to your on-premises as well. So let's take a look at why you would want to use Tape Gateway for your backups. The Tape Gateway provides a drop-in replacement for your physical tape-based backups. The Tape Gateway emulates physical tape infrastructure, scales seamlessly with your business needs, and eliminates the operational burden of provisioning, scaling, and maintaining a physical tape infrastructure. The Tape Gateway is integrated with multiple backup software applications, and you will get to see later what those are. The Tape Gateway can also be deployed on multiple platforms that I will also talk about later on in the presentation. With the Tape Gateway, you can cost effectively and durably archive backup data in Amazon Glacier. It offers lower TCO than physical tape-based backups. And with Tape Gateway, you can continue to use your existing backup apps and your existing backup workflows. You simply switch from using physical tape library backups to using virtual tapes on the Tape Gateway. Then going to the right-hand side, top here, the Tape Gateway is enterprise ready, meaning it offers all the compliances listed here, which are needed by our customers operating in different industries. And when the backup software ejects the virtual tape, the Tape Gateway archives that tape to Glacier, and it does so in read-only mode. If you retrieve the tape, it will come back in read-only mode to your virtual tape library. So you can be assured that no one has tampered with the data returned to the tape or mistakenly writes new data to the tape once it comes back from Glacier into your library. The Tape Gateway leverages HTTPS connection to the cloud for secure data transfer, and you can also use server-side encryption in S3 or use your own KMS keys to encrypt data at rest in the cloud. And finally, with respect to the performance, Tape Gateway provides you the ability to cache your most recent backups locally and offer faster recovery so you don't have to fetch that data from the cloud. This also helps our customers save on cloud AWS costs. With a tape gateway, you can restore or retrieve a tape from Glacier to your virtual tape library in Amazon S3 in 3 to 5 hours, rather than having to put in a special request to your offsite vendor to get your physical tape. In Tape Gateway's case, you can retrieve an archived tape on your own from AWS Management Console. The Tape Gateway also compresses the data prior to synchronizing with the cloud, and the data compression factor will depend on what type of data you're backing up and whether that's compressible or if another storage element has already compressed the data prior to arriving at the gateway. Next, let's take a look at what's new with the Tape Gateway since the beginning of 2018. As you know, we like to hear from our customers and work constantly to roll out new features that benefit them. Here's a list of all that we have added to the Tape Gateway. Generally, we've added support for more backup apps such as Dell Networker, Nova Store Data Center. We also added support for Gulf Cloud in the US and Singapore regions, which means you can also deploy Tape Gateway for backups in those regions. We added support for KMS back in June, so you can optionally configure encryption on tapes using AWS KMS managed keys through the Storage Gateway API. So this is in addition to the default option of using server-side encryption in S3. So KMS just provides you another option now to encrypt your data. We also added PCI DSS compliance. We added support for hardware appliance as a platform alongside VMware ESXi, Hyper-V, and Amazon EC2 instances, which were supported before. And most recently, just a few days ago, we qualified Tape Gateway with newer versions of backup software such as Veritas Net Backup, Veritas Backup Exec, and Quest Net Vault. The prior versions of these backup applications were already supported before, and we just qualified the newer versions. We also added support for Bacula and IBM TSM backup apps for the first time. These apps were not supported before, but there was demand from our customers to make Tape Gateway work with these apps also. So we have listened to them in this case. And for Microsoft DPM 2012 and 2016 backup software, there was an issue with tape barcodes not showing up in the DPM software. So this issue has been fixed as well now, so the tape barcodes will display correctly in Microsoft DPM. And finally, getting more speed out of the Tape Gateway was always a top ask from our customers, and we have made enhancements to the software to increase the throughput performance of Tape Gateway by up to 40% depending on your workload. Now let's dive deep a bit and understand how Tape Gateway works and how you can do backups. The Tape Gateway emulates physical tape infrastructure such that it provides virtual tapes, tape drives, and media changer. The virtual tapes are presented to your backup software using iSCSI connectivity. Once the backup software recognizes the tapes, you can start backing up data to those tapes. Now, when you're writing backups to the tapes, the data is stored in the virtual tape library, which is in Amazon S3. And when you decide that you've completed your backup and no longer want to write to a tape, you can eject or export the tape from backup software. This operation will cause the Tape Gateway to place that tape in read-only mode and subsequently archive it to Glacier. The gateway will move the tape from virtual tape library in S3 to virtual tape shelf in Glacier. And here is a list of all the backup applications that are supported with the tape gateway. As you can see, we have covered almost all popular backup software within enterprises and are always looking to expand to additional options. Please feel free to send feedback to us via forums or your account teams on what other backup software you would like to see work with the tape gateway next. Now let's talk about how the restore of a tape works. So you have two options to do a restore of a tape. The first is you can restore the tape to an on-premises gateway. It can be any tape gateway on-premises and not only the one you backed up your data from. And the second option is you restore the tape to a gateway in cloud for disaster recovery. Both the methods are available and customers use whichever method they prefer and is best suited to meet the use case. The slide here shows the restore use case for in-cloud recovery. So what you will do in this case is you will spin up an Amazon EC2 instance with the Storage Gateway AMI or Amazon Machine Image and create a tape gateway. Now you can restore or recover tapes that were backed up prior to this new gateway. The gateway retrieves the data from Amazon Glacier to virtual tape library on this new gateway, which is expected to take 3 to 5 hours. And once the tape is in virtual tape library, you will be able to see the tape in backup software. And then you can utilize the backup software to read data from the tape and do the restores as necessary for your recovery. The slide here shows cost comparison between tape gateway and on-premises tape-based infrastructure. It shows an example scenario where every month 100 terabyte is written with 1-year retention period. Also during this month, a customer does one tape retrieval, that is they recover one of the many tapes they had backed up before for recovery purposes. And as you can see, the tape gateway is about 40% less than the on-premises tape in this example, and it provides significant savings over physical tape-based infrastructure. And this doesn't include the intangibles such as freeing up your time that you would normally spend on backup infrastructure management to do other activities that focus on your core competencies and drive business forward. So as you can see, the tape gateway offers a compelling value proposition to start using AWS Cloud for your tape backups. So as I was talking earlier, you can deploy tape gateway on a number of form factors. The left-hand column here describes that you can deploy tape gateway on a VMware ESXi hypervisor or a Microsoft Hyper-V based virtual machine. And typically you would use this option in your corporate data centers or offices when you have an existing VM infrastructure already. You have your own VM clusters and you have the IT staff to manage and run these clusters. And you have a VM to spare for your tape gateway needs. The second option here in the middle is to use an Amazon EC2 instance in AWS to run your tape gateway. We support a variety of instance sizes, and the storage gateway is available as an Amazon machine image on those instances from the AWS marketplace. You would typically deploy tape gateway in EC2 when you have a need to use cloud as your DR option, or you want to do a quick proof of concept on the tape gateway functionality. And the third option here is the hardware appliance, which is a new option that we launched in September of this year. We see remote locations or branch offices as the ideal use case for hardware appliance, as it provides a simple out-of-the-box experience to get connected to cloud and consume the storage services from AWS. We did a webinar on this last month, and it is available on YouTube if you would like to learn more about the hardware appliance. So this table here describes the minimum and maximum for both the gateway and the tape specific parameters. I wouldn't go through the entire table as it's self-explanatory, but let me discuss some aspects that are worth mentioning. On the tape gateway, you will need to allocate the cache size and the upload buffer size. The cache is the local storage that's used by the tape gateway to store and acknowledge the read and write IOs from backup software before you upload that data to the cloud. And then the upload buffer is a staging location for data waiting to be uploaded to the cloud. Now, as far as the tape-specific parameters are concerned, a single gateway can hold 1,500 virtual tapes in the tape library. However, there is no limit to the maximum number of virtual tapes in archive, that is the tapes that are in Glacier, and there is no limit to the size of all the tapes in the archive. You can store as much data as you want in Glacier without running into any soft or hard limits. One other aspect that's worth highlighting is that you can create however many virtual tapes you want on the gateway, of course subject to the 1,500 number that's listed here, and allocate storage for those tapes upfront, but you will only be charged for the data that you write to those tapes. Next, let me dive into some best practices for the tape gateway, starting with the basics first. As I was showing you earlier, you have multiple platforms or options available to you to deploy your tape gateway on. This include ESXi, Hyper-V, the newly launched hardware appliance, or tape gateway in EC2. So you will want to select the right type of platform for your needs. VM or hardware appliance is ideal for on-premises deployment, and EC2 is ideal for recovery of data in cloud or quick proof of concept, as I was mentioning earlier. The second one here is allocating the appropriate CPU, memory, network, and storage resources necessary for running the tape gateway to meet your backup workloads. Generally, you will get better throughput performance out of solid-state drives than spinning drives. NVMe drives can also get you higher performance. And you would want to attach virtual disks to your VM directly from a storage area network instead of a hypervisor native file system. The improved disk performance generally results in better throughput and more IOs for the application. When you provision the disks in a gateway setup, we recommend that you do not provision local disks for the upload buffer and the cache storage that use the same underlying physical storage disk. Also, it's generally, if a data store that is backed by only one physical disk or is backed by a less performant RAID, such as RAID 1, can also lead to poor performance. So those are some of the things you would want to watch out for your storage gateway setup. And lastly, make sure that you're choosing the right network connectivity and speed that meets your backup and restore requirements. So for network connectivity, AWS provides several different options, including establishing a private network via VPN or the internet, or using a direct connect over a 1 gig link or a 10 gig link. You need to essentially ensure that the network bandwidth between your backup application and the gateway and between the gateway and AWS can sustain your application read and write needs. Now I'm turning over to advanced best practices specific to tape gateway, and these are more generic in nature, but will really help you understand the kind of things you should watch out for. The first one here is that you need to back up, if you need to back up a certain amount of data in certain time period, essentially your backup window, within which you should get your data to the cloud so as not to hog the systems or the network that disrupt other users. The tape gateway generally fares better in terms of throughput when you're writing backups to multiple tapes at the same time. You also get more throughput by deploying multiple gateways in parallel. We'll provide concrete guidance at a later time on how you can use tape gateway throughput numbers to come up with the number of gateways you need to back up your data to the cloud in a specified time period. The second option here is to optimize tape gateway I/O performance by using a larger block size, provided your backup software supports it. The tape gateway supports block size up to 1 megabyte in size, so you can increase the block size from the backup software to improve I/O performance. Now, we recommend setting the block size of the tape drives in your backup software to either 128K or 256K or 512, whatever is supported by the backup software at max. And when you do that, you also need to ensure that the host initiator that's connected to the tape gateway also supports that block size that's used by the backup software. And finally, you say you want like faster restore times. And the local cache will really help you there to store and access backups locally, while at the same time having a copy in the cloud. As I was mentioning earlier, the max cache supported on tape gateway is 16 terabytes. So depending on your backup data size and how far you anticipate needing to go back for your data, you can size your cache appropriately. And this is the last slide before I hand it over to my colleague Mohammed for the demo. You can track the performance of your gateway using AWS CloudWatch metrics. So the storage gateway provides CloudWatch metrics at no additional charge, and these metrics are recorded for a period of 2 weeks in AWS. The slide here for the CloudWatch metrics is not meant to be comprehensive, but I just wanted to show you a few key CloudWatch metrics that are worth keeping a close eye on as they relate to measuring performance between your backup host and your gateway, or between your gateway and the cloud, as well as your cache. You can visit the Storage Gateway User Guide to get a comprehensive understanding of the metrics that are available to you. In general, the data throughput, the data latency, and operations per second are measures that you can use to understand how your application storage that is using your tape gateway is performing. And note that the throughput and latency data of a tape gateway is based on all the virtual tapes on that specific gateway. The cache metrics are important to understand also, so you can know how much of your I/O is being served locally, that is from the cache, and how much data has not been persisted to AWS by the gateway. You can also set alarms when the metric values cross certain threshold, so you can take appropriate actions before something starts to become a problem. So to summarize, there are a lot of metrics available to you to measure the health and performance of your gateway. Some of them are, I've listed them here. For a comprehensive list, you can certainly visit the AWS Storage Gateway User Guide. I think I've talked enough now, so let me hand it over to my colleague, Mohammed, to walk you through a demo.
Hello, and thank you, Pavan, for your presentation. My name is Mohammed, and I'm a Global Solutions Architect in AWS. Today, I'm going to show you a demo on backing up a tape in 10 minutes using Storage Gateway. In this demo, I've already pre-deployed a storage gateway on an EC2 instance with a recommended memory size. If you want to deploy storage gateway on premises, let's say on VMware, you would deploy a VM and allocate to it the recommended memory sizing, and then afterwards you would allocate local storage for the cache and upload buffer. You would also need to activate that gateway, so you do that by opening the correct network port requirements as listed in the AWS documentation. So in this demo, I would show you how to create new virtual tapes on the gateway, connect the gateway to the backup application, import new tapes into the backup application, start a backup job, archive a tape, and retrieve a tape. The tape gateway needs to be assigned two local disks, one disk for the cache and one disk for the upload buffer, and hence I'm getting this alert that I need to allocate local storage. In this session, I'm using Storage Gateway on EC2. So since I am using EC2, as shown here, so if I go to the instances and then go to my tape gateway, I assigned the storage to the instance as ABS volumes, as shown here. So 2 volumes of 10 gigabytes are attached to that instance. In the normal situation, when you are using your own VM, so on either Hyper-V or VMware, you would assign local storage to your VM. But since I'm using it on EC2, I assigned ABS volumes. So going back to the Storage Gateway console, I'd click on my tape gateway, and then I would assign it the local drives or the local ABS volumes that I attached to the instance. So first one I would choose for the cache, and then second one I would choose for the upload buffer. As you can see here, there is a hint that the minimum recommended size is 150 gigabytes for the upload buffer and for the cache as well. But since this is used for demonstration purposes, then I'm using 10 gigabytes. I'll click on save. And then as you can see, the alert is gone. So now basically the tape gateway is ready to be connected to the Windows client. But we would need to create a tape where we can back up our data on. So to create the tape on the storage gateway, you would need to go to the Tapes tab and then click on Create Tape. And then I would choose one tape and then capacity, let's say, of 100 gigabytes. And then I would give it a barcode of AA, for example. And then I would click on Create Tapes. And then it's done. And the tape is available. Now we are ready to connect our tape gateway to the Windows client and perform the backup operation. I am here at my Windows client. I want to discover and connect to my tape gateway iSCSI devices. To be able to do that, I will go to the iSCSI Initiator desktop app, then I will go to the Discovery tab. So I will go here, and then Discovery tab, and then I would click on Discovery Portal. As you can see, it asks me for the IP address to connect to on port 3260, which is the iSCSI port. Note here that there is a requirement that your client is able to reach the gateway on port 3260. For full network requirements, I advise checking the Storage Gateway public documentation. So now I would go back to the AWS console, and then I would go to the EC2 service, and I would check the instances and the tape gateway instance, and I would write down that IP of the gateway, and then I would go back to my Windows client and then paste that IP here. Clicking OK, and then going back to the Targets tab. As you can see here, the targets appeared. So these targets are 10 targets for the tape drives and 1 target for the media changer. I would then connect them all very quickly. and then clicking OK. Now we are ready to discover the library and perform backup using the backup software. The Storage Gateway public documentation shows you the information on how to test the supported backup softwares with the Storage Gateway. So if I go here to that menu using your tape gateway and then testing your tape gateway, you would see all the supported backup software listed here, and then you would see how you can test it with the Storage Gateway. So for example, here I would follow these steps for testing backup exec with the Storage Gateway. So going back to my Windows client, after we discover the targets, I would open backup exec. And then I would go here and then configurations and settings, backup exec services, and then restart all services. This will allow me to discover the library of the storage gateway on backup exec. Now the restart of all the services is done. So I'm going to close that and then I'm going to go to storage. And here you can see the robotic library, which is the 10 tape drives of the storage gateway. And then here is the media changer. So going to the slots, I would like to import the tape that I would back up the data on. So I would right click, import, and then import media now. And then a message would appear, respond OK. And then now I should wait till the tape appears. And here it is. Now let's see how can we back up a sample backup file to that tape. So here I have a backup file called backup file of 50 megabytes. Let's see how can I put it into that tape using backup exec. So I close that and then I would go here to backup and restore, one-time backup and then one-time backup to tape, and then just wait for a few seconds. And then now I'd click on edit. I would deselect all and then just click on my file, which is the backup file. And then I click OK. OK. It should run now. So as you can see here, it's backing up. And if we go to the jobs, you would see a full backup job that's going on right now. So its state is active, and then job state is active queued, and then it's preparing, then it's processing. And if you go here to the storage in the meantime, and then go back to all storage, you would see that the tape is already imported to one of the tape drives since there is a backup operation on that. So going back to the job monitor, it's already successful. Now let's go back to the storage and check the tape drives. So as you can see here, the tape is already not in the tape drive anymore. And if you go to the Storage Gateway console and check the tapes, you would find that the usage of the tape is 50 megabytes, which is the backup file that I put on the tape. So now going back to my Windows client, let's say I'm not in need of using that tape here anymore and I want to archive it for archiving purposes. So that basically means on AWS moving the tape from S3 storage to Glacier storage. So what I'm going to do here is that I'm going to right click on that tape and then I'm going to export media now. Then gonna wait for the message to say everything is okay. Going back to the Storage Gateway console, if I refresh on this, it should be in the archived state as shown here. So now the tape is lying in Glacier and it can be retrieved anytime to the Storage Gateway as a read-only tape, meaning that you cannot write anymore to that tape, but you can read the data that you backed up. You want to retrieve that archive tape and restore backup from it. So to do so, you would go to Actions and then Retrieve Tape, and then select your tape gateway, and then click on the Retrieve Tape. And then it will load some time, and then it would say that the retrieve has started. So for testing and simplicity, I already have a tape here that I retrieved to the tape gateway. So let's see, how can you see it back in your backup application? So I would go to my Windows client. Now I go to Storage, and then I would click Import Media now. Then I would respond that everything is okay. And the tape should appear here in the slots, as you can see. Thank you very much for your attendance. I hope you found the demo useful. Getting back to Bhavan.
Thanks, Mohammed, for the demo. Hope your audience got a good taste of how you can use Tape Gateway for your backup needs. In summary, Tape Gateway is a great drop-in replacement for your physical tape-based backups that offers data durability, accessibility, and security for your data in cloud at a compelling cost. So you may ask, where do I go to learn more on Tape Gateway? And I've listed here the URL that you can go to where we have posted a lot of resources to help you get started with the Tape Gateway. And we are at the end of today's webinar. I would like to thank you for taking the time to join us for the webinar and keeping us engaged with your questions. Hope this time has been well spent for you and that you're walking away with a good understanding of Tape Gateway, its benefits, how it works, how you can use it, the best practices to run your gateway optimally, and the metrics to keep an eye on from this webinar. Thanks once again for joining us today, and have a good the rest of your remaining day.